All right, we're back here with another SAS tutorial, and in this one what we're going to do is we're going to show you in SAS how to conduct panel regression analysis. In the previous tutorial, what we did was we showed you how to conduct regression analysis using cross-sectional data. So you can think of cross-sectional data, for instance, in the previous tutorial, what we did was we estimated some equation for a cross-section of stocks. We had thousands of stocks. Now, when we do panel regression analysis, what we're doing is we're running regressions on panel data, or sometimes it's called longitudinal data, which consists of both cross-sectional and time series observations. Let me explain. So I'm going to work here with a data set. You can see here in my code, I've specified a SAS library name, A. It's pointing to this directory. And there's a SAS data set that you'll have access to called stock data by ticker date 2018 December. So let me run this here, and then I'll explain what the data will look like and show you some of the ways that you can analyze this data. So here we have, so we've worked with a similar data set here. It was a huge data set. It consisted of thousands, 8,000 stocks, and for every day during 2018. So what I've done is I've taken that data set and I just grabbed a subset of that data set where I grabbed a couple of thousand. I think I have maybe 1,200 stocks here. And I just have every day in December of 2018. For instance, this is December 3rd, 2018. December 6th, 2018, the 10th, 11th, 12th, 13th, 14th, and so on. Okay, and I have a group of tickers. I shrunk this panel data set in order to run some regressions that don't take so long to run, so that you're not waiting on SAS during this tutorial. Okay, so that's what the data looks like. You can see, so there's this ticker AAL, and I have data for this ticker for all days in December. I have something like 20,000 observations, which consist both of about 1,200 stocks and a month's worth of daily time series data. As before, I've got the lowest price during the day, the highest price during the day. This is the closing price during the day. This is trading volume. This is my stock return, the closing bid price, the closing ask price, and shares outstanding. Here's my open price. And then I've conducted, consistent with previous tutorials, a bunch of variables here. So this is the bid-ask spread in percentage terms. This is share turnover, which is going to be the volume divided by shares outstanding. My market capitalization is going to be my stock price. I used my closing price times shares outstanding times 1,000. Shares outstanding is in the thousands. And so that's my market cap. So this particular stock, let's see, is an $18 billion market cap, has an $18 billion market cap. Range volatility is the natural log of the highest price minus the natural log of the lowest price. So that gives me a daily range. It can be an approximation for volatility. And then what I've done is I've taken the natural log of my market capitalization, the square root of the price, and turnover as a percent. So here's turnover as 0.0142. I just moved the decimal place over 2 to get 1.4279%. Okay, so these variables, again, this is not an econometrics tutorial. I just want to run a model here using panel data. We're not asking anything very interesting here, but I just want to conduct some analysis using this panel data set. So the first things first. So in the previous version, our previous tutorial, what we did was we ran proc reg plots equals none. So I don't want the output to plot the various graphs. It slows down my computer a bit. And so what I want to do is I want to create a model statement. Let's say spread equals turn percent log cap square root of price and range volatility. And we've used this in previous, a model very similar to this in previous tutorials. And so I'm just estimating OLS. I have cross-sectional and time series observations. When I run this, the output's going to look just the same. There's my parameter estimates. Those are my standard errors, my t-values, my t-stats. Here's my r-squared, my root mean squared error. That should all look familiar if you've gone through the previous tutorials, right? I can conduct more robust analysis by controlling for white standard errors. I mentioned this in the cross-sectional regression analysis in the previous tutorial. If we're wanting to control for conditional heteroscedasticity, I can do that with that white statement at the bottom of my, at the end of my model statement there. So that gives me white, Halbert White's robust standard errors, and those are those corrected standard errors. My t-stats are going to be slightly different, of course, because my standard errors have been adjusted for heteroscedasticity. However, when we're using panel data, longitudinal data that has cross-sectional and time series observations, we bump into a problem here. So the first problem is that the standard errors could be clustered across stocks. So think of stocks within a particular industry, right? And we're looking at the bid-ask spread of those stocks. Maybe there's some industry component that makes those standard errors cluster across the cross-section. And there might be some market-wide shock that occurs and affects all of the stocks in this sample the same. So you might have clustering both at the stock level in the standard errors and clustering at the time level in the standard errors. So we can easily adjust for that by estimating a procedure called proc survey reg, data 1. And what I'm going to do is I'm going to allow for clustering, or I'm going to control for the clustering by ticker. Right? Let me just copy and paste this. I'm going to control C that model statement so I don't have to retype it. Let me get my solution here. So this accounts for clustering across the cross-sectional observations, which is my ticker symbol. When I run that, it spits out my parameter estimates. Those are OLS estimates with standard errors that account for this potential clustering. Okay. But I might also want to cluster across date as well. So here I'm doing two-dimensional clustering by ticker, by date. Right? This is going to adjust my standard errors to account for the possibility of clustering. And you can see that SAS kicks those estimates out fairly quickly. Okay. So I could account for the clustering in the standard errors using proc survey reg. Another thing that we might want to do is we might want to conduct other panel regression techniques using proc TS-CS reg. Proc TS-CS reg stands for time series cross-sectional regressions. So this is a procedure, a SAS procedure that's directly tied to panel regression analysis. What I do here is I create an ID statement, ticker and date. Before I do this, I have to sort the data by my ID statement. So let me sort that data using the procedure sort. Proc sort data equals data 1 by ticker date. Then let me use my model statement here. And there are at least 4 options that we can use after our model statement. So what we want to do here is maybe to get rid of the possibility that one particular event during December 2018 is affecting all stocks. What I want to do is I want to account for fixed effects. The econometricians listening to this tutorial will understand what fixed effects are. Basically what they are is I can put in dummy variables for each stock, actually n-1 stocks, every stock but one. And I can put in dummy variables for every date -1, t-1 dummy variables. And what that's going to do, that's going to give me fixed effects by stock and by date. These dummy variables are going to take away any possibility that outliers are driving my parameter estimates. Okay? So I can do this in this procedure, the SAS procedure, TS-CS reg. I can say at the end of my model statement, fix 1. And that means I'm going to just have one-way fixed effects estimates, and that one-way fixed effect, or in other words, the dummy variables are only going to be for n-1 ticker symbols. Okay, let me run that real quick. And I'll show you what that looks like. It creates dummy variables for every cross-sectional observation except for one. So there you have it. There's the cross-sectional observation for the first variable. That's my estimate, right? And basically that fixed effect is pulling out any possibility that one particular stock in my sample is driving all of my results. Okay? If I scroll down here, you can see I have I have 1140 dummy variables, cross-sectional dummy variables, and then here are the parameter estimates that I'm interested in. And as before, turnover is negatively related to bid-ask spreads. Market capitalization is also negatively related to bid-ask spreads. The price is positively related, and the volatility is positively related. That's the same as what we found in the previous tutorial and in the OLS estimates that we did just a few minutes ago in this tutorial. One other thing that we can look at. Let me scroll up here. Forgive me for taking so long. So this is this TSCS reg procedure. Watch what happens here. So I have an F test for no fixed effects. So this value here, this F value, tells me whether or not I test the null hypothesis that there is no fixed effect, that there are no fixed, I don't need to include cross-sectional fixed effects. So you see that this F value is very high. The probability is less than 0.0, the probability value, the p-value is 0.0001. So I'm 1 minus 0.0001 confident that I need to include cross-sectional observations. Okay, so that F test tells me that I need to include these cross-sectional fixed effects. I can say in my model statement F or fix 2, and that's going to include not only cross-sectional fixed effects but also time series fixed effects. When I run that, it's going to take a second. It's producing a whole bunch of dummy variables there. Okay. Again, it's telling me that there are fixed effects that I need to. The F stat is big enough to tell me that I need to include fixed effects. I'm going to scroll down here. Here are all my cross-sectional fixed effects, the parameter estimates on those dummy variables. And then look, as I get down here after the cross-sectional fixed effects, you can see there are my time series fixed effects. So those are a dummy variable for every day in December 2018. You can see on the third day of trading day of December, there was a positive and significant fixed effect. Okay, and as I scroll down, after controlling for two-way fixed effects, I still have parameter estimates that are consistent with previous findings. Turnover and market cap are negatively related to bid-ask spreads. Square root of price and my measure of range volatility are positively related to bid-ask spreads. So that's how you would conduct a two-way fixed effect regression. For the other econometricians that are listening to this, maybe you want to account for random effects. I'm not going to go into detail about what random effects are, but it's possibility that there are random effects that are driving our results. There's a Hausman test that gives us that tests for the null hypothesis that we have random effects. You can see that the random effects, the critical value is big enough to reject that null hypothesis. So it doesn't appear that I have random effects across the cross section. If you don't understand what I'm saying, just know that this is something that econometricians care about. I can run two-way random effects model using proc TSCS reg by at the end of my model statement saying ran2. It's going to produce a Hausman test that tells me whether or not that's I need to control for those things. The Hausman test critical value is big enough to reject the presence of random effects. So it looks like if I were to run this analysis, I would need to include two-way fixed effects there. Let's see, is there anything else that we need to talk about using panel regression? I think that's about it. So again, we're looking at SAS procedures that allow us to run regression analysis using panel data in this tutorial.